Do you need to quickly generate field regions to show CCTV camera coverage in Revit? I have done one here and it's okay. However, if I have to do the same for the other hundreds of cameras in my building, it will take me ages. Let me show you today how to create an automation script that can process all of your CCTV cameras in one go. It would be something similar to what I did here using RV Camera Planner. However, I will show you how to do this in Dynamo so you don't have to pay for any additional Revit plugins. Using the same principle, you'll be able to generate for each camera multiple field regions for different visibility ranges. For example, identify, recognition, observation, detection, and so on. Let's see the script we will build together today. First, we need to specify a few inputs. The family instance of our camera in this room. Let me click here and then select the CCTV object. Next, let's click here and select the room that contains our CCTV camera. Then, we can select the view in which our field region will be generated. And finally, I can also select the field region type that will be used. Let me click Run now. And there we go. The new field region has been generated to show what the CCTV camera can see, considering the room's shape and all the obstructions inside it, like walls or columns. After this, I can also use RV Camera Planner to visualize what the camera can see as a new 3D view. We can also do this with Dynamo, by the way, so make sure to subscribe to see how to do this in the next video. If you don't have much time and just want to run this script right away, simply find in the video's description a link to download this script directly. If you, however, want to learn to code this yourself, let me show you how right now, step by step. To start, let's create a new script in Dynamo. I will change the run mode from automatic to manual so it won't hang on us unexpectedly. I will now add a Python node to the graph and open it for editing. However, this is not a good script editor, so I'll type the code out in Visual Studio Code instead and copy it back into Dynamo at the end. You will find the same Python script in the Dynamo file that you can download for free. Just copy all of that and then paste it into the Python node here. We can now save the Python node and now start specifying inputs to it. First, let's select the view in which we want to create new filled regions for CCTV coverage. I'll just pick the view showing in the background there. Next, let me add in here two new nodes for selecting model elements. I use the first one to select the CCTV camera instance in my view. For the second node, I will select the room containing my camera family instance. For the last input, we need to specify which field region type the script should use when creating new regions. Let me get the surveillance zone region type in here. With that in place, let's start connecting those input nodes to the Python script, starting with the two selected elements. Now, if I remember correctly, this Python script will output two sets of data in its result. Let's add in here this code block to unwrap those two outputs. I can then use that result data to create an isovist from our CCTV camera's location point. Let's drop in here an isovist from point node to do that. I can then give it the camera location point and the room boundaries from the Python script and the code block. Let's run the script now and see what happens. There we go. We now have a surface that shows the portion of the room that is visible from the CCTV camera location point. Our next step is to convert this surface in Dynamo to a field region in the Revit view. To do that, let me first extract the outer perimeter curves of the surface. Next, I can explode that curve into individual lines using this geometry.explode node. You can see them in the output right here. Finally, let's add in here a fill region by the curves node. This will create the actual filled region for us in Revit. To do so, we need to give it the boundary lines from the explode. Additionally, it will also need to know the view hosting the new filled region and the region type to use when creating the actual region. Let's run the script again and voila! We now have the isovist surface in Dynamo as a transparent and fully editable field region in Revit. Of course, if you look closely, this field region is a bit bigger than the one created by RV Camera Planner. This is because the isovist node in Dynamo assumes a 360-degree vision angle around the camera location point. In reality, a CCTV camera like this one usually has a much smaller vision angle. No problem at all. I can simply edit this field region and then draw two lines from the CCTV camera point to limit the isovist to the actual vision angle of the camera. Let's say for this one is 90 degrees. We can do a quick boundary trim for the field region and then finish the edit. And there we go. That's a lot more realistic. As you can see, however, doing this for each and every camera would be time consuming. On real projects, we usually have for each CCTV camera a parameter that specifies its vision angle, like this one here. I will show you how to make use of this parameter to generate the field regions more precisely in the next video. However, here's what it's going to look like. We will create something similar to the settings section of RV Camera Planner. As you can see, there's an option here to select the CCTV camera parameter for vision angle. You can even specify a fixed angle value for all cameras if you want to. For now, I'll go with the parameter-based approach. Now when I select all cameras and start generating the regions, the plugin will read the vision angle of each camera and create each field region accordingly to that value. I can now place just a quick angular dimension to ensure that for this camera, it is exactly 75 degrees. And there you have it. If you want to try RV Camera Planner completely for free, simply use the link in this video description. There's also a link in the description to download the script we built together today.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.